So, hello everyone, hope you're doing good. Welcome back to my channel, and big congratulations to all of you if you have completed the daily recall challenge of March. Right, the questions at the end of the March daily recall challenge were slightly hard, but the courage to continue counts, right? So, today we are at the day one of the April daily recall challenge, and we have each question in front of us. It's question number 704 binary search. See, ideally, whenever I think of this word binary search, see, binary what it means, and search is obviously a easier term to understand, but what binary means, we'll see that now, right? So what they are asking us is they are giving us a number array in our integer array, which is stored in ascending order. See, there is a hint here. It's a ascending order array and integer, right? Target, which we have to search in this array, right? Write a function to search target in numbers array. If target exists, then we have to return its index. Otherwise, we need to return -1. And see, there is one challenge given here. If you are in a interview, then they will also get such a challenge. Initially, they will ask you a sorting algorithm randomly. You can use anyone, anything. But later, they will give these conditions like if the array is sorted, what complexity you will target. Like this, you will be getting answer questions, right? So see, these are hints for you to approach to answer. How you have to use these hints, we'll see now in this question. We'll see practically, and obviously, I'm going to trace and show you how it's being done, right? So here is a nums array. You can clearly see it's in ascending order. Everything ascending means from smallest number to its bigger one, right? Every number will be bigger than its previous number, right? And there is a target array. Four and yeah, we have to see that nine exists in this location, so we're returning its index, right? So how to design this solution? See, first before going to the solution, try to understand what binary means. Binary means we will see. I will have a starting index, I will have a ending index, and I will have a middle index. Middle means it will be in the middle of the starting and the ending index. What we'll do is we'll compare the middle index. For example, see in this case you can see it has a length. If we go from index 0, it will have a length of 5, 0, 1, 2, 3, 4, and 5. Okay. Let us say this is the middle. See, these two ideally comes in the middle, right? If you calculate these two are in the middle of the array, right? But I will say let us take this part preferably as the middle array. What I will do is I will compare its value with that of 9. What I can see definitely 9 is going to be greater than 3, right? So what one thing is very clear now in my mind that 3 will not be in the left of this, right? 3 will never be in the left of 3 because in the left of 3 all are smaller than 3, and I can clearly see that 9 is greater than 3. So what advantage we get? We remove this total part from our search. That definitely 9 is not going to be present here. What we are doing, we are removing a half, means we are dividing the array into two parts and we are removing one of its half. That is what is meant by binary. Binary means at a time we will remove half of the array from search. So we will focus only on the remaining half of the array from 12 to 5. Okay. In this part, what is the middle element? Definitely it's 9. We will compare 9 with the target, and in this case it matches. So we will remove return a 4. Right. So what we did? See here, two things are important. First thing is we have to declare a low and high. What is low is the starting index. What is high is the ending index. From this, we'll declare a middle number. In middle number, see if in this case you can take either 3 or 5 as a middle number, right? And there's no issue in that. Define a middle number which will be always in the middle of low and high, right? Once we're in the middle number, compare that number with target. If it matches, well and good, return the index. If it doesn't match, compare if the middle number is less than the target or greater than the target. Accordingly, remove the part of the array which is no more needed. For example, in this case, target, which is 9, was greater than 3, which is middle. Okay, 3 is middle, right? So we are removing this left part of the array, which is -1, 0, and 3. We are removing it because we know in left of 3 all are smaller numbers than 3. So definitely 9 is greater than 3, which is going to present this part. So we are totally removed from consideration. Now we'll search only this part. This is what is called log and complexity, right? At a time we are removing half of the array and we are focusing on the remaining half. This is what will be called the log and complexity. Whenever you're writing algorithm which removes one part of the array at a time, then it comes out to be log and complexity, right? So T of n in this case will be T of n by 2 plus O of 1. That's why if you calculate it will come as log n complexity. Now coming to the coding part of it. See, it's a very simple one. As I told, I will declare my low, at least low here, right, as 0. Similarly, my high will be length of n, length of the, see, n is length of nums, right, -1, which is the index, right. This follow will run till my low is less than or equal to high. Once it becomes greater than high, we will stop. We are calculating the middle. How we are calculating the middle? See, middle. See, it's very simple function. So h minus l by two. But see, h minus l by two will give me the half number of it. This half needs to add it to the previous l. See, for example, when we have this part of the array, okay, the middle should be present in this part only, right? It should not be somewhere else. That's why I'm adding. See, in this case, L is here, right? L is the five. Five is L, okay, and H is 12. So L should be in middle of that, right? That's how to ensure that I'm adding H minus L by two, which is the middle one, to the L index. L means the starting index. From to starting index, let us say L is zero. I'm adding a value, the half value. The half value is being added to the starting index. That's how mid is calculated, right? Then how? See, if my target is present in that middle array, simply return it. If my target is greater than, just try to imagine here, 9 was greater than 3. So what we'll do, we'll shift our starting to middle plus 1. We'll shift our starting to middle plus 1, right? As simple as that. Because the left side of L is no more needed now, okay? So we'll shift our target to mid plus 1. If the other way is 2, suppose 9 was less than 3, we should focus only on the left part then. Because, see, 9 is less than 3, suppose. Let us say 2. Target is 2 here, right? 2 is less than 3. So definitely it should be present in the left part of it. So we'll discard the right part. In this case, we'll replace high with middle minus 1. We are discarding the right part. This for loop will continue till L is less than equal to H, and the tracing I will show you now. And finally, if this return statement is not getting executed, that means we are not finding the target in any of the places. Finally, we return minus 1. Now, coming to the tracing part quickly. See, time collapse I have already told you is going to be log n. How? T of n is equal to T of n by 2 plus O of 1. Okay? If you find using, see, you have to use master theorem here. If you use the master theorem, you will get the time complexity as O of log n. Some more questions I have put in my channel as well, which you are supposed to use master theorem to calculate the time complexity, and I will post the answers as well now. Right now, coming to the example one. See, this is my numbers array, and the index I have written below. Right, this is my numbers array. With we have to find the target name, and these are the indexes. Initially, L is zero, H is five, which is the last index, and just try to calculate mid using this formula. Right, L is zero, so 5 by 2, which is 2.5, we have to take integer of it, which is 2. 2 plus 0, which is 2. So the mid will be 2 here. What is the element at index 2, which is 3? What is whether 9 is greater than 3 or not? Definitely it's greater than 3. So what will happen? My low will shift to mid plus 1, which is 2 plus 1. 2 plus 1 is 3. Right? Now calculate the mid using L is equal to 3 and H. See what happened? This part of array is discarded now. Right? Now we'll shift. Now my L will become 5. Okay. My H will remain as 12. And we have to calculate mid. What is mid? See 5 minus 3, which is 2. 2 by 2, which is 1. 1 is added to 3. It becomes 4. So my middle now is this element. Compare target through this. Definitely matches. So we stop and return this index, which is 4. Right? That's what we are doing here. Yeah. Now coming to the second example. Target here is 2, which is not present. Let us see how it works. So again, same thing. H is 5, which is the last index. L is 0, which is the starting index. Mid is calculated. 5 minus 0, which is 5, divided by 2, which is 2.5. 2.5 with the integer part, which is 2. So 2 plus 0 is again 2. So my middle index is this. How to see, compare now this with the target, whether target is less than this or greater than this. Definite target, which is 2, is less than this. Target is 2 is less than this. So we will discard this part of the array. I will make my high as mid minus 1, which is 2 minus 1, which is 1. Okay. I'll make my h as 1. It was 5 previously, now it is 1. Okay. Now calculate the mid value. You will get mid equal to 0. Now compare mid, which is minus 1, with 2. Definitely in this case, see, this is the mid of 0, right? Sorry, the nums of 0, nums of mid. So it is definitely less than the target. So we make ls mid plus 1. Mid is 0. So L will be 0 plus 1, which is 1. Okay, this is where, see, always you have to check whether this condition is being met or not, at least less than equal to h. In this case, it is less than equal to h. Again, calculate. You will get mid equal to 1. What is mid equal to 1? Which is 0. It has value 0 at one index. Compare target with this value. Definitely target is greater than that. So what we'll do? We'll do mid plus 1. Mid is 1. plus 1 will be 2. So my starting index will be 2 now. But see, L is less than equal to H should be met. In this case, we can clearly see it's not getting met. So we need to stop here. And finally, we'll come out of this loop because this condition is no more false, so no more true. Finally, what we have written? We have to return minus 1, which is being written here. This element does not exist, right? See how many steps we do. Totally 3 iterations. If we do a linear search, definitely we will need to search for 5 times. But how many times we searched? We did it only for 3 times, right? And then we stopped. Similarly, if you can see here, we did it for 2 times. So see, if you now just compare it with the linear search, what we'll do, we'll compare each and every element, right? Because we don't know in which order the elements are present. Let's compare each and every element. So in this case, definitely you would have made five. If the length of the array is five, you would have to made 5 comparisons. But in this case, we made only 2 comparisons and we got the answer. So that is the advantage of binary search. So I will again repeat what binary means. Binary means at a time we are reducing half of the array, we are eliminating half the array from the search area, right? That is binary. And search is simple search terminology, right? And how is O of n complexity? O of log n complexity. So just write it down if you have a pen and paper with you. T of n is equal to T of n by 2 plus O of 1. Why T of n by 2? See, at a time we are reducing the time complexity by half because we are eliminating half of the array. And how we are doing it? We are doing it by doing a simple comparison. So O of 1. So T of n is equal to T of n by 2 plus O of 1. Now I'll try to find the time complexity. You will get it is O of log n using master theorem. If you're not sure what master theorem is, please comment below. I will make a video on it. There are some more practice questions as well regarding the master theorem in my channel. You can watch out that as well, right? And ultimately, we're returning minus one. So yeah, friends, that was all for today. And definitely, if you have completed the March daily code challenge, a big congratulations to you once again, right? So thank you once again.